Hello and welcome to my channel. Today we'll be learning about Vieta's formula, and to understand that we will first be learning about elementary symmetric polynomials. Let's say we have three variables a, b and c. So we have three variables and this will allow us to form three elementary symmetric polynomials e1, e2 and e3. So let's figure out what they will be. An elementary symmetric polynomial is basically the sum of products of n combination of the variables. So for example, elementary symmetric polynomial 1, this will be the sum of all possible combination of one variable. So that will just simply be a plus b plus c, because combination of one variable we can do it in three ways: just a, just b and just c, and we are adding them all up. Number 2 will be the sum of all of the possible combination of two variables. So we can combine them like ab, bc or ac. So this will also have three terms added together: ab plus bc plus ac. And for the third polynomial, there is only one way to combine all three of them, and that will be ABC. A, B, C. Let's take another example with four variables A, B, C and D. So what is E1 gonna be? It's just going to be the sum, because there is only one way to make one combination, then that is just take one of them at a time. And now when we come to E2, we can do it like AB, AC, AD, BC, BD or CD. So we'll have to sum all of those together. Elementary symmetric polynomial 3 is going to be the sum of triplets, which is going to be ABC plus ACD plus BCD. And the fourth one will simply be the product. So as we can see, if we have n number of variables, then for that we will have n elementary symmetric polynomials. The first one is just going to be the sum of them all. The last one is going to be their product. And the second one is going to be sort of their pairwise product. And you can see that it will always have a certain amount of terms, which we can... So for elementary symmetric polynomial 2, for example, we have four variables and we need to choose two of them. So the way to do that will be 4 choose 2. That is how we express that. And so that will have 4 choose 2 amount of terms, which turns out to be 6. So for any number, n number of variables, the kth elementary symmetric polynomial will have n choose k number of terms. So now let's get into Vieta's formula. We will be considering the roots of a polynomial of nth degree. So let's say the roots are R1, R2, R3, and let's say it's a degree 5 polynomial. So it will be up till R5. So thus it states that the kth elementary symmetric polynomial is equal to this expression over here. So that is minus 1 to the power k into a to the a sub n minus k by a sub n. So what is this? Let's see an example. So let's say we have an equation like 5x to the 4 plus 3x cubed plus 9x square plus 3x plus 1. This is just a random equation polynomial that I made up. So we will see that this will also have 4 roots, r1, r2, r3 and r4. So the relationship between those roots, the first elementary symmetric polynomial, if you remember, is the sum. So therefore r1 plus r2 plus r3 plus r4, this will be equal to, so this is the first elementary symmetric polynomial. So we have negative 1 to the power 1, which is just negative 1. So negative of a sub n minus k. So here the degree is 4 and the k is 1. So we will have a sub 3, which just means the third coefficient. So that will be this one right over here, which is 3. So minus 3 divided by a sub n is the leading coefficient, which is this. So the sum of all of the roots, no matter what they are, complex roots, real roots, any roots, their sum will be minus 3 over 5, all of them. And we can also take the second elementary symmetric polynomial, which will be the pairwise product, like r1 r2 plus r1 r3 plus r1 r4 plus r2 r3 plus r2 r4 plus r3 r4. So this pairwise product of the 4 variables, this will be equal to, this time it's minus 1 to the power 2. So you can see it will alternate between sign. If we take the third one, it will be minus again and so on. So this will be a sub n minus 2, which is a sub 2. So that is the second coefficient after the leading coefficient, which is this 9 over here. So that will be 9 over the leading coefficient always stayed the same. This is going to be 5. And with this we can take out the products of the roots, sum of the roots, anything we want to take out. So this is an example question that I have made for you. 8x to the 4 plus 4x cubed plus 7x squared plus 5x plus 2, that is our polynomial. And it has 4 roots obviously because it's 4th degree polynomial. And we need to find the sum of roots and the sum of the square of roots. So the sum of roots, as we have seen before, it's the first elementary symmetric polynomial. So it will be negative 1 to the power 1 minus, so it will be minus, and it will be a sub 4 minus 1, which is a sub 3 by a sub 4. So here are a sub 0, 1, 2, 3. So we will have 4 in the numerator upon 8 in the denominator. So our sum of roots is the same as minus 1 upon 2. Now what is going to be the square of these roots? You might notice that this is not an elementary symmetric polynomial. So we will have to engineer it to become an elementary symmetric polynomial. So if we consider this, we can see that it's similar to their sum whole squared. It's not the same, but it's similar. So if we take their sum squared, if we take this sum whole square, what do you think we'll get? Well, we'll get this whole quantity again, but we'll get an extra term added. So this is going to be equal to r1 squared plus r2 squared plus r3 squared plus r4 squared. But this is going to have an additional factor of 2 times r1 r2 plus r1 r3 plus r1 r4. Again, this is just the pairwise product of them, and this is a formula that you will probably learn. So this quantity that we want to figure out is equal to this quantity square minus this 2 times this quantity. We can just shift it to the other side. But what you might notice is this and this are both elementary symmetric polynomials. So we can equate this to this, the first e1 squared minus 2 times e2. So we can write this down that this quantity is equal to e1 squared minus 2e2. So now we can easily calculate it because we know the values of e2, e1 and e2 based on this polynomial. So e1 we already have the value, it is minus 1 by 2 whole squared. Let me just get another pen. So it will be negative 1 by 2 whole squared minus 2 times, let's equate e2 on the spot here. So it will be negative 1 to the power 2, so it will be positive, into a sub, it will be this coefficient a sub 2 because the degree is 4, minus 2 is 2, so the coefficient of x squared, which is 7. So 7 upon the leading coefficient, which is 8. So we can cancel this out. So our answer will be 1 minus 1 by 2 square will be 1 upon 4, and minus 2 times 7 upon 4 will be like this. So this is going to be minus 6 upon 4, which is minus 3 upon 2. So we can even figure out the values of the things which are not elementary symmetric polynomials. And in fact we can take any symmetric polynomial. A symmetric polynomial is basically where you can exchange all of these and it will be in the same order. So you are doing the same operation to the variables. So any symmetric polynomial, we can represent it in the form of these elementary symmetric polynomials. So that is useful for solving these questions.